Good morning everyone. Today we are going to learn about single phase energy meter and its principle of operation. And also we'll be going to learn about the construction of single phase induction type energy meter. First of all, what is energy? Energy is nothing but it's the total power delivered or consumed over a particular period of time. Okay, and also what is the unit of energy? You know that the unit of energy is kilowatt hour. One unit means 1 kilowatt hour. Then what is an energy meter? Energy meter is nothing but an integrating instrument which measures quantity of electrical energy supplied to a circuit in a given time. And this energy meter, single phase energy meter, possesses low friction. It has high torque weight ratio, and this induction energy meter is inexpensive, and it must be very accurate, and it retain accuracy over a wide range of loads and temperature conditions. And now let us see the principle of operation of single phase induction type energy meter. In induction instrument, the deflection torque, as we have discussed in the previous classes, that there will be about three torques. One is deflection torque, another one is control torque, the third one is damping torque. In this single phase induction type energy meter, the deflection torque is produced due to the reaction between flux of an AC magnet and eddy currents induced in a metallic disc. Now let us see the construction of single phase induction type energy meter. It can mainly consist of four parts, that is, number one, driving system, number two, moving system, number three, braking system, and the last one is registering mechanism, that is registering system. Let us see the first one, that is driving system. This driving system consists of two electromagnets, M1 and M2. M1 is nothing but is the current coil, and M2 is nothing but is the pressure coil, and also it consists of copper shading bands. The core of the two electromagnets are made of silicon steel laminations. They are series magnet M1, which is excited by the line current, and the shunt magnet M2, which is connected across the supply voltage, which is to be measured. Now let us see the diagram here. As we have discussed that there is two coils. One is current coil. This one C1 is the current coil, which is connected in series with the line. Whereas the other coil, that is C2, this C2 is in parallel, means it is across the voltage V. Current coil is a series magnet which produces a flux phi 1, which is proportional to the line current and is in phase with the line current. And the other coil, that is pressure coil, also called as a shunt magnet M2, produces a flux phi 2, is proportional to the supply voltage, and this lags behind the supply voltage V by 90 degrees. And this is achieved by the, means this lagging is achieved by the copper shading bands. Copper shading bands or power factor compensator is provided on the central limb. As we can see in the previous diagram, these bands are provided on the central limb, and their position is adjustable, means we can compensate, we can adjust the power factor, and their main function is nothing but phi 2 in quadrature with the applied voltage V. Now the second system is moving system. This it consists of an aluminum disc, and the disc is mounted on a light alloy shaft placed in the air gap between series and shunt magnets. This moving system, this aluminum disc, we can see in the diagram also, and it rotates on a steel pivot. This pivot is screwed to the foot of the shaft. A pinion is engaged shafts with counting or registering mechanism. And the third one is the braking mechanism. This braking consists of two permanent magnets called as braking magnets, and these braking magnets are placed diametrically at the edges of the aluminum disc. And the aluminum disc moves in the field of these magnets. The aluminum disc provides the braking torque, and this permanent magnet's position can be adjustable. Hence, the braking torque can be adjustable. And the last one is registering mechanism. The function of the registering mechanism is to record continuously a number, and this number is proportional to the revolutions made by the moving system. Mainly, this recording mechanism is provided with a worm and a worm wheel. The rotation of the spindle is recorded on a cyclometer, and the ratio of the wheels are designed to give energy for a set of revolutions of the aluminum disc. Okay, in this way, the register mechanism will be there, and it is provided with various gear mechanisms. A train of reduction gears drive a pinion, and the pinion is on the rotor shaft. A series of 5 or 6 pointers rotate on a dials. The dials are marked with 10 equal divisions, and the gearing between pointers. Each pointer advances by one tenth of a revolution for a complete revolution of the adjacent pointer on the main rotor disc in the train of gearing. From this, we have learned about single phase energy meter, which consists of shunt magnet, which is energized by the pressure coil, and the series magnet, which is energized by the current coil. The flux is produced by the current coil is proportional to and is in phase with the line current, and flux produced by the pressure coil, that is phi 2, is proportional to the supply voltage and lags behind the supply voltage by 90 degrees. The position of the copper bands is adjustable, and this copper shading band is adjusted to bring the flux of the pressure coil in quadrature with the supply voltage. And this aluminum disc, which is positioned on the pivot, rotates on a steel pivot. Braking magnets are placed at the edge of the aluminum disc, and this braking magnets provides the braking mechanism. Okay, the recording mechanism consists of worm and worm wheels. The rotation of the spindle is recorded on the cyclometer. Now let us see a small quiz on this presentation. Aluminum disc is a part of driving system, moving system, braking mechanism, and resisting mechanism. Nothing but we know that it is the part of moving system. Position of copper shading bands is adjustable, non-adjustable, rigidly fixed, none. It is, yes, the answer is A, adjustable. Current coil is wound on series magnet, shunt magnet, braking magnet, none of the above. Current coil is always is wound on the series magnet. So answer is A. Coil wound on the shunt magnet is pressure coil. Flux produced by the pressure coil is proportional to the supply voltage, lags behind voltage by 90 degrees, both A and B, none of the above. Lags behind the voltage by 90 degrees. Mechanism which records number of revolutions of the disc is moving mechanism, registering mechanism, both A and B, none of the above. Registering mechanism. Now let us see some frequently asked questions from this. In this, the question will be like this: explain the construction and principle of operation of a single phase induction type energy meter with a neat diagram. Okay, from this, we have learnt about the single phase induction type energy meter. Thank you very much for listening.